Good evening, everybody. This is Stereo Police. For me, it is, well, I usually do these videos either really early in the morning or really late at night, so it's not that late. It's about 7 in the evening now. It's after work, and this is something I've been wanting to talk about for a little bit. I've got a lot of issues with, there's a lot of hyperbole, a lot of overstatements, a lot of myths, a lot of falsehoods about speaker cables. And I just want to go into two of them tonight, just food for thought. And I want to get into some technicalities about them. I know this type of video is amongst my least popular videos, but I don't care. I'm not in a popularity contest. Doesn't matter to me if one or two people on the planet get something out of this. I'm cool with it. Because I think this is highly educational, and even if you don't agree with it, it's still food for thought. All right, I'm going to be blacking this part out when you see it, but I'm going to be reading this. What I'm reading is something from a website from a speaker cable manufacturer, and quite frankly, I cut this and pasted. I don't even know who it is, and I don't care. I'm not trying to harm the reputation of any company or person, but this is just typical of the type of hyperbole you hear, and quite frankly, I think the type of myths and sometimes the type of flat-out lies you hear about speaker cables, things that are propagated from companies on down to audiophiles. These are speaker cables that about a meter long, and they cost $1,745. And the gist of this is this first myth out of the two myths I'm going to discuss is about the material. And it says here that any precious metals, talk about precious metals, and they talk about tonality, clarity, dimension, other factors are greatly affected by which metals are used, which I think is a steaming pile of you-know-what. And then they go into silver. Silver is a fast metal. What does that mean, fast? And then they get into the fact that it has the lowest impedance rating of all precious metals used in audio today. And I think I know what they're talking about, and I'm going to get into that. Then it says the effect silver has on music, and they talk about enhancing speed and clarity. Details become crisper, soundstage gains depth. They use pure silver, ensuring the best quality and warm lush and speed and detail and snappy brights and clarity and all the buzzwords. Well, if you've attended Audiophile University, you'll remember valence bands of electrons. And here we look at silver. Silver has 47 protons, 47 electrons, and there's the valence electron. This is the electron that gets bounced off, and this is the electron that carries the charge. And if we compare that to copper, copper has 29 protons and 29 electrons. There's the valence electron. He's the guy that gets bounced off, that carries the charge. If you've attended the very first Audiophile University, you'll know this. And the big difference between silver and copper is the valence electron in silver is out in one additional shell, so it's a little further away from the protons. So it's a little more loosely bound, shall we say, in layman's terms, because opposite charges attract. So silver is a slightly better conductor. And we measure these intrinsic properties of materials by virtue of this measure called a resistivity, which, by the way, this is incorrect right here, ohms per meter. It's actually ohm meters, not ohms per meter. That little slash is incorrect. And silver is this, and you're going to know what I'm talking about by resistivity in a minute. But so silver is a better conductor. And if you attended Audiophile University, you'll remember this chart right here as being conductors, and down here we have insulators. So what I'm going to do is give you a demonstration of the differences between copper and silver in a 3 meter, for example, 14 gauge speaker wire. Now what I'm going to tell you is a 14 gauge speaker wire has a cross-sectional area in millimeters squared of 2.08, and I've already converted that to meters squared because we're going to need things in meters squared because resistivity is in units of meters, ohm meters. So it's a little tiny cross-sectional area. And we're going to start out with copper. But first I want to tell you how we can determine the resistance of a given wire if we know its cross-sectional area and we know its length. Well, I already told you we're going to consider 3 meters. And I told you we're going to consider 14 gauge, which is a typical gauge of many speaker wires. And we know its cross-sectional area is this many meters. So we know its cross-sectional area. And we know its resistivity right here from this chart, copper. It's this little tiny number here, 1.68 times 10 to the negative 8, the exponential. Very, very, very tiny. So let's run that number. You don't need to be concerned with your math unless you want to back check me. I'm cool with that. So I'm going to run this equation right here. I'm going to run this equation right here. We have a 3 meter wire. We know its cross-sectional area. We know its resistivity from the chart. And we can calculate the resistance of that wire. So I've done the resistance of a copper wire given those specs, and I came out with 0.024 ohms, a very small number. We're going to run the same calculation for silver. Silver has a slightly less resistivity, 1.59 versus 1.68. So it is intrinsically a better conductor. I'll agree with that. But how much better in the real world? How much of a difference will it make? So the cross-sectional area remains the same, the length remains the same, only resistivity changes. So I run these numbers and I get 0.023 ohms. I mean, there's no difference. That is absolutely, positively negligible in the real world. There's no difference. Nothing. The difference between silver and copper, between a 3 meter length of speaker wire, is zippo, nada iota. So that nonsense that I just read you, are there other characteristics of silver that make it faster? What do they even mean by faster? If you remember from Audiophile University, electrons, current is not the flow of electrons. It's the flow of charge. And electrons, when they're in a wire, they don't travel in a straight line. They travel in a zigzag, sometimes even go backwards. They travel in a zigzag pattern. But it's the charge, ultimately. And you can go back and watch it. I'm not going to rehash that here. And if you really think hard about that, there's a wire with a voltage. A voltage is a pressure that's moving that charge. And there's no reason I can see, even thinking about, for those physicists out there, thinking about Maxwell's equations, there's no reason I can see, given the atomic structure of silver and copper, that there would be any difference in the speed of the motion of charge through a silver wire versus a copper wire of equal cross-sectional area and equal length. I call BS. If someone's willing to provide evidence otherwise, please do. Let's move on to, I'm going to black this out too. I'm going to read myth number 2. I'm going to black this out. And this is from another speaker company. And I'm not interested in disparaging any companies or anybody. I'm just trying to dispel myths. And this is about gauge of wire, and this is about something called the skin effect. And you'll hear this a lot discussed by audiophiles who usually have no idea what the hell they're talking about. And here's what this says. I'm going to try to paraphrase. Different frequencies ride at different depths of the wire structure. The high frequencies, mids, and lows tend to separate, causing time and phase errors in the signal. Bullshit. This is commonly known as a skin effect. Large gauge wires, the problem gets even worse, and phase and timing errors. Bullshit. Sound stage is reduced, timbre is distorted. Bullshit. Therefore, we only use a small gauge wire. Okay, all right. Let me tell you what the skin effect is. The skin effect typically gets more concerning at radio frequencies. Audio frequencies are nowhere near radio frequencies. And what happens at higher frequencies is the charge tends to concentrate towards the skin of the wire, or the outer diameter of the wire. The current flows out here rather than at the core. All right, and that's actually a real thing that needs to be dealt with, and mostly at the much higher frequencies than the audio frequencies. I'm going to give you evidence of that. So the skin effect is frequency dependent and diameter dependent. So at higher frequencies, you need to use a smaller diameter like a stranded wire, of little tiny strands. And in the skin effect, we often talk about something called skin depth, and that's the depth at which, given the frequency and given the diameter of the wire, that's the depth at which a certain percentage of the charge will be concentrated. The current density, we call it. All right, so let's take a look at our once again at our 14 gauge wire, which has a diameter of 1.63 millimeters. And I have a chart here I pulled, and again, I have sources for everything. Feel free to correct me or fact check me. I could be wrong. I'm definitely not an arrogant person. I'm very humble, actually. And I'm up here on the line for silver, copper, gold, and aluminum. They're all very similar in this regard. So what I've done is I've drawn a cross section at about 15. Okay, skin effect is negligible, if nothing, down here at 100 to 1 kilohertz. Don't even worry about it. So I've gone up here at the worst case scenario, somewhere around between 15 and 20 kilohertz, which most, I've chosen 15 kilohertz. Hardly anyone can hear beyond that, and there are hardly any instruments that produce sounds beyond that. So we come up here, we intersect the silver, copper, and gold line, and we come over here, and we're roughly at a skin depth of about 6 millimeters. That's where that's about the depth at which the concentration of charge will travel on a wire, 6 millimeters. And we know that the diameter of a 14 gauge wire is 1.63 millimeters. So let's come down here. We have our wire that has a diameter of 1.63, which means it has a radius of 0.8. So if the skin depth in our worst case scenario is 0.6, I'm going to draw a 0.6 right here. That's the skin depth. So still the vast majority of charge will be traveling in the vast majority of the area of the wire. There's absolutely nothing to be concerned about. Now I'm going to say one other thing, and this is even more ridiculous. If you have stranded wire, the gauge is measured based on the total diameter. But the strands inside are these little tiny things. Check it out for yourself. These little tiny things. So their diameters are like that. Way smaller than 1.63. So there's absolutely positively no issue with the skin effect. Stereo Police. I call BS. Over and out.